The figure below shows a square inscribed in a circle with a radius of 3. What is the area of the shaded region? So in order to find the area of the shaded region, we're actually looking for the area of the entire circle minus the area of the square, and then we can divide that by 4 because we're looking for this one portion of the circle, and since all of these little portions are all going to be equal, we can go ahead and find the missing area and divide it by 4, like the entire area here. So in order to do that, let's go ahead and find the area of the entire circle first. So let's call that a subcircle. That'll be the entire circle. And that actually will equal pi r squared. We already know the radius here, so that's 3. So we have pi times 3 squared. Oops. 3 squared times pi, which gives us 9 pi. So now our shaded portion is going to be 1/4 of this whole area circle minus this. So we're going to hold on to that area of the circle for now. We're going to need to find the area of the square next. So the area of the square is going to be our sides, the one side times the one side. So let's go ahead and let's call this S for side. This will also be S. All of the sides of the square will all be S because the sides of a square are all the same. So we're essentially looking for S squared. Now, in order to find S, we're going to need to use this radius of the circle. Now, if we drop this and complete the diagonal here, we can complete, whoops, that's not ideal. So let's go ahead and complete this diagonal here, creating this right triangle. So we can ignore those guys for a second. Let's just erase those so they don't get in our way. So this is a right triangle right here. We have a couple ways that we can find this S. We can use the Pythagorean Theorem. S squared plus S squared will equal not 3, but the entire hypotenuse, which would end up being 6. So we can use the Pythagorean Theorem if we would like. An alternate option would be to recognize that this is actually a 45, 45, 90 triangle, and we can use the ratio of sides. So either way will get us there. Let's go ahead and use the Pythagorean Theorem. So finding S, let's set up the Pythagorean Theorem. So S squared plus S squared should equal 6 squared. Now simplifying this a little bit, we'll have 2s squared equals 36. Dividing out by 2, we have s squared equals 18. And taking the square root, we have s is equal to the square root of 18. Now normally we would get a plus or minus here, but remember s represents a length. So when we take this even root, we can throw out the minus option, or the negative square root of 18, because our length can't be negative. Now if s is square root of 18, we can go back up to our area for the square, and we can plug in our square root of 18 value, square it, and we'll end up with 18 as our area for the entire square. So finding the area for these 4 portions, we can go ahead and take our circle and subtract our square. And let's just go ahead and use that orange for a second just to show what we're talking about. If we take the area of the circle and we subtract the square, we're actually going to end up with all of this area. Now, since we only want the shaded region, we're going to subtract those areas, but we're going to actually divide that remaining orange area by 4, giving us this one gray piece. So let's go ahead and let's do that over to the side here. We can take our shaded region, so area of, well, let's use a capital A to make it all consistent. So area of the shaded part is going to equal 1/4, that looks like a 9, 1/4 times the area of the circle minus the area of the square. And we have both those values, so let's go ahead and start plugging in. So 1/4 times our area of our circle is 9 pi minus the area of the square is 18. And we could actually factor out a common factor of 9, and we'll end up with a 9/4 times pi minus 2. And if we take a look at our answer choices, 9/4 times pi minus 2 is actually answer choice B. So that's our correct answer, is answer choice B.